race fans, car lovers, motorheads, anyone with a need for speed. We're going to play with Matchbox cars today and maybe learn a little science along the way.
Hi, I'm Brandy and I'm the mom behind Aunt Bindy's Bookshelf. I am here to help you as you help your kids to learn and grow. Today we are going to do that by playing with Matchbox cars. We're going to build 3 different ramps at 3 different heights and we're going to run the same car down the ramps. Then we're going to collect the data of how far those cars traveled and use it to talk about the science behind why cars travel further when they run off of ramps that are higher. So either just build the ramps and run cars down them, just observe, or stick around for the science. Either way, kids are learning, growing, and having fun. I'm going to drop chapters in the description. Check those out if you need to come back. Okay, if you are going to build ramps with us, here's what you're going to need. I'm using magnetic tiles to build my ramps. You can use Legos, you can use wooden blocks. You just need something that's going to be able to build 3 different ramps and that's going to have a really easily discernible height difference. So you need to be able to measure whatever the height difference is. So whatever that looks like for you, go ahead and use that. You're going to need a smooth surface to run your cars down. If what you're using is already smooth, definitely use that. That'll work great. Magnetic tiles aren't smooth. They have little lips, so we're going to use a little piece of cardboard. A toy car, Matchbox car, Hot Wheels, whatever, some kind of a toy car. You're just going to need one because we're going to run the same car multiple times. The observation table, I will have a link to a free printable of this in my in the description. So go ahead and print this off for kids to write their measurements down. And taxi dog. Every month we pick a picture book of the month and we do a science experiment, a craft, sensory tables, fun facts. We do all kinds of stuff, math activities, reading activities, all based around this book. So you can do the experiment without the book, but it's so much more fun if you do the whole unit. Make sure to subscribe if you have a car lover because we're all about cars for this month.
First, we need to build our ramps. We're going to build 3 different ramps, and I don't have enough tiles to build them all at the same time, so we're going to build the largest one, run the cars, break it down to the next size, and go from there. You can do that too. Okay, we're going to start with our longest ramp and break down as we go. The great thing about using the magnetic tiles is we have a very definite height increase. We're going to go from 4 squares high to 3 and then 2. When you're building, you'll want to do something that's equally easy to visualize. One important part of science is running multiple trials. That way we know we don't just have one funky trial. We get a good idea of what actually happens most of the time. So we're going to run our car 4 times on each ramp height. We'll measure how far our car went each time and record it on our table. This is called collecting data and gives us cold, hard facts to analyze. We're going to repeat this for the other 2 ramps, running trials, measuring, and recording our data. And then we come back to the lab to run the numbers and see what they tell us. I've put all our data into a bar graph, and now we get to see what it tells us. It looks like our average distance traveled for the shortest ramp is 20.93 inches. And for the middle ramp, it was 26 inches. For the tallest ramp, it was 31.3 inches. Now let's plug that into our bar graph. Look, this graph is telling us that the higher the ramp, the further the car traveled. Is that what you thought would happen? Why do you think that is? Let's talk about it.
So what we're seeing when we see the tall ramp make the car travel further is an increase in gravitational potential energy. Whew, that is a mouthful. What in the heck does that even mean?
Let's think about it like this. What if I had to crank the car up to the top of the ramp? How many cranks do you think it would take to get to the top of the shortest ramp? Do you think it would take more or less cranks to get to the top of the middle ramp? And what about the tallest ramp? The taller the ramp, the more times I'd have to turn the crank to lift the car to the top of the ramp, right? Each time I turn the crank, I'm using energy to turn my arm and the crank, which means I'm using more energy to get the car to the top of the highest ramp. Same thing is true when I just lift the car to the top of the ramp. The higher I lift, the more energy I use to lift the car. Now let's think of that energy I'm using like gas, something that fuels the car. The more gas I put in the car, the further it can go, right? Well, the more energy I spend to lift that car, the more gas or energy it has to spend to travel down the ramp. So when I lift the car higher, it has more gravitational potential energy and it travels further.
All right, what do you think? Did your cars go as far as you thought they would? Did they travel the way you thought you would? Did you have fun trying? If you did, hit the like button for me and make sure to come back. We do a different science experiment every single month. And remember, we do a craft, sensory bins, different activities, math and reading games, all wrapped around that one picture book unit. While you're waiting for some more science videos, you can check out some of the videos we've already done here. And I'll see you next week for more videos.